Sir, please wait for 2 minutes.
Okay, sir.
Hello, Baghel Saab.
Yes, sir.
Can you hear me,
Yes, ma'am.
Baghel Saab?
Yes, ma'am. Hear me.
Okay, okay.
Now we can start.
Okay, sir. So first of all, thank you, all of you. So I welcome the resource person, Dr. Prashantkumar Patel, and participants to this session on study of some special function using MATLAB. The resource person, Prashant Kumar Patel, is an assistant professor at the Department of Mathematics, Sardar Patel University, Vallabh Vidyanagar. He has 9 year experience at undergraduate level and 5 years experience the postgraduate level. He holds a PhD mathematics from SB National Institute of Technology, Surat. He did his MPhil mathematics from Department of Mathematics, Sardar Patel University, Vallabh Vidyanagar, and MSc mathematics from Department of Mathematics, Sardar Patel University, Vallabh Vidyanagar. BSc mathematics from St. Xavier College, Gujarat, University, Ahmedabad. He qualified NET CSIR exam in mathematical science in June 2014 with an All India rank first under lecture category. He has published 29 papers, out of which 5 papers are in communication. He has presented many papers at the National International Conference and delivered lecture in workshop also. So please I invite Dr. Prashant Kumar Patel for his presentation. Sir, please.
Yes, thank you very much, Mangal sir, for introducing me for this audience. And thank you very much, the organizers, to give me a chance to deliver this talk. That is a study of some special function using MATLAB. I'm more concentrating on MATLAB rather than a special function because I think so many of the participants are, as Sukla sir says, that they are freshly they want to join the research, and for that sometimes it is needed to have a programming skill of certain languages. So what I have planned is I more focus on MATLAB, and if time permit, we'll discuss regarding the special functions. So this is my outline of the talk, that I'm first of all give some introduction regarding what is MATLAB is and what everything is there. Creating a script file, saving script file, executing script file, and so we'll do some exercise, and I'm also giving you some exercise as a homework. We'll see what is the gamma function, Kochar symbol function in MATLAB. Everything they are doing in MATLAB. Okay, so let us first of all, I will request all of you can go through this site, that is matlabwork.com. I'm sharing the link in the message, means in the text box. How to go back to the sharing. I'm just posting into the chat box. You can go to that link, and those who have not a MATLAB in their laptop, they can work online with this link. It is rather than giving a lecture, it is actually hands-on training. So it is better that you can do the hands-on with what I'm doing here. Okay, so you can go to that and then sign in. If you don't have an account, you can create an account. It's just 1 minute job to create an account in this MathWorks. For example, I already have an account with my institute email ID. So just I click and I'm just signing in to that. So it will having such type of window. Then you can go to the Open MATLAB Online. It will take few minutes according to your internet speed, and such video means such window will appear. Okay. So shall I give you few minutes to do this, or I can continue? So those who have a MATLAB already there with you, they can directly open the window and do it. Those who don't have a MATLAB in their laptop, even though you can do this one in the mobile also, you can open this with the mobile also, you can do this. Same thing will open. So see, I have a trial version. This MATLAB 20 R22. This is my trial version I'm using here, 22. So there are lots of MATLAB versions are available. Depending on your requirement, you can use them. Here I've just downloaded the trial version for this MATLAB, and the 22 MATLAB 22 is look like this. Let us give some introduction about this Windows. What are the which tabs are here? The same thing is there for your online math work. Okay. So guys, if you are not following, you can just tell me, you can stop me in between the lecture. It is fine. See, these are the three windows I can see here. The first window is known as a command window. In that command window, we can write any command. For example, A is equal to 3. When I write A equal to 3, so I'm just writing A equal to 3, then semicolon. Then it will not printing whatever I have typed. So if I put this arrow here, means this semicolon here, then it will not print the yes. Once I have defined this variable here, A is equal to 3. This is my workspace. This is the workspace. You can just see that there is a equal to 3 value is there. So that is a workspace. So whatever the variables we are defining, it's defining if it's come under this workspace. For example, I can just say x is equal to pi. So pi is written like this. So it says that x is equal to 3.1416. So that is the way MATLAB works. So these are the two windows. This is the current folder. Usually the current folder in your laptop means whatever the program you are. So there is some participant saying that there is no audio. So it is, my audio is clear or some problem is there?
No, that's fine.
Okay,
That's
fine.
fine.
Thank you.
Your audio is fine.
The audio is okay, no
Current
problem.
folder, there is a current folder is there. So it is usually every, you can change this also, but probably in when you install a MATLAB, everything is means it is in C drive. Then whatever the path you want to give the that will locate it into.
कुछ नहीं वो पता नहीं क्या सेटअप से ले गया सेट करके
So this is about this MATLAB. This three windows which is already there. Then there are some tab here on the top side. This is a plotting tab is there, and this is a app tab is there. Basically, in this lecture, I am just going through plot tab and few of this home tab they are here. So the first things you can see that it is a new script. If you just click on it, it will be one script file is open. It is untitled 2 as a name. So this is my creating a script file. That is the first topic which I have written here. So how to create a script file. So to learn how to create a script file in the and execute them in MATLAB, a script file are created by users and sequence of MATLAB commands in it. So when I have in this command window, I have to type everything, whatever I'm one by one. Suppose I say that 2 plus 3, it will show me the answer 5. Okay, so this is my one sentence, one command I have written here. And in the script file, there is a sequence of commands will be there, and we need to write. And the extension for this MATLAB commands for this files will be of .m. So this is the extension of this MATLAB command is there, and they are known as M files. A script file is executed by typing the name without .m and at the command. For example, if I can have any script file, if I have, then you, in the command prompt, you just directly type whatever the script file name is there, and it will run. There is another way is to run also is there. So just click on this run. So, or you can just press the F5. That is also one of the key to run a script file. How to create and write and save the script file, and how to execute the script file. Let us see that. So we need to write the script file to create a draw a unit circle and select. So as I did here, and what is my objective? My objective is to create a script file which draw a unit circle. Okay. So in the file menu, you have to go. So here I have just gone here in new tab. It is already there in here, and then I just write percentage. Whatever you write after percentage, for example, if I can write here percentage Prashant, then after percentage, whatever you write, it is not affected by the MATLAB. MATLAB is, it is colon is there. That means after that, it is not command. So it is usually when you write any script file, it is better to write the information regarding that command is what you have written, because after sometimes suppose after 1 month you just looking at the same file and you want to recognize that what I have written in that file, then you cannot recall. So it is better that all the times whenever you create a script file, write some introduction about what you have did in that script file. So what we are doing is we are just creating a circle, a script file to draw a unit circle. So this is I'm doing. So if you want to draw a unit circle, what you will do? I want answer from the audience. What you will do to draw a unit circle? To define a variable first of all. So what you require? What are the ways you can draw a circle? Suppose I want to draw a circle with the radius 1, unit circle. I already did it. Yes, anyone? Okay, so what we will do is we just write a theta. The theta, that means you know that if you have a circle, then every coordinates of that circle have two components, that is x and y. If you write down this x and y in polar coordinates, then it will have cos theta comma sin theta if you are on unit circle. Okay, so this is your x and this is your y, and according to this value of theta, so if theta is moving from 0 to, let's move all along the side to 2 pi, it will create every point on that circle. Okay, so that is the fundamental idea to create a circle or draw a circle. So what I'm creating one variable, that is a theta. Theta is equal to, now you want a see in the MATLAB is depending on the numerical values. It is not going to discuss, yeah, it is going to discuss about the continuous values, but for that you need to define a variable in some different way. So it will not take the value continuously from 0 to 2 pi. So you have to break, so you have to take the values from 0 to 2 pi. So there is a command called line space between 0 to 2 pi. So as we know that pi can be written in this manner and 2 into pi. So if you want to write down 2 pi, then it is 2 star pi. 2 star pi means 2 into pi. And in between 0 to 2 pi, I want 100 points. So if I can just run this, only this command, then the shortcut is you select that line and press F9. Then you can see that it will create a vector that is named as theta. Here you can just say that in workspace it is created a vector 1 cross 100. So it is given a row vector of 100 length, which having a values between 0 to 2 pi. Now what is our x? What is our x? X is equal to cos theta and y is equal to sin theta. And then we need to plot. So this is my variables. X is equal to x cos theta, y is equal to x sin theta. Now I need to plot this x versus y. Okay, so it will plot. So there is a command called, see, this cos is command. That means it is a function. And this function is applied to this theta. Sine of this. So what is x cos theta will gives you? X cos theta is also creating one vector with 1 cross 100, but the value, for example, here it is 6.28832 is there. The cos value of that vector will be created. So if you can just type cos of theta, then it will create that vector. Similarly, sin theta, and then we are plotting. That is an inbuilt function is there. It's called plot xy. Then I want axis, that is x axis and y axis should be equal. So just I am writing equal, and title of that graph that we create, we give the name called circle of unit length or unit radius. Okay, so then I'm just selecting all this and press F9. This is the one way is to doing this. Another way, so it is taking some time. Okay, so right now it is processing. So it is just see that here it is stop. Now it is completed and it new window is open up and it is creating one circle with radius 1. Okay, so this way you can create a plot function in the graph is there. Fine. So I hope it is understood, means everyone is understanding what I'm explaining. And it is better that you can do it simultaneously what I'm doing here, because it is better. Then you can see what is happening at your end. Okay. So now, right. So now how to save this? What we have done, how to save that? So you just press Control S if you are working in Windows, then Control S is command. Different operating system have different uh, terminologies or commands for saving a file. So I'm just give the name called circle. So it is now it say that circle M, and here in my current folder there is a circle M command is there. There is another ways to run this entire file. Just click on run, it will run this. Okay, so this is the way you can do this. Okay, now we get back to the MATLAB and type the command as below and command window to execute the script file. So if you can just type here in the command window help circle. So that is my this name of this file which is there. I'm just writing help circle. So whatever the few lines you have written here on the top of your code, it will appear. So it will say that this circle file, circle.m file contains this, a script file to draw a unit circle. So that's why it is better that whenever you are writing any command or any file, any script file, then you should have some introduction about what you are doing in that code is better for long term. And you just write circle, then it will run the entire program, whatever you have written. So in command prompt, you can just write circle here, then it will execute the whatever the code you have written in that file. Okay, so there are actually four ways to run the file. The first one is just go here in the file, press F5, so entire file will be run. Select everything and then press F9. Then entire code, the particular code is run. The another way is to by running the clicking on this run function here. And the third way is to just type in the command window whatever your file name is there. Fine. Let's go further. Now this is the exercise I'm giving you, that show the end center of the circle, modify your script file, that is circle.m, to show that center of the circle on the plot and show that circle with the a plus sign. So can somebody guide me what to do this? So here I have plotted this. Plot this x and y. So now I want to plot in this function, in this figure, here 0, 0 point. The second question was change the radius of the circle and modify your script m file to draw a circle with arbitrary radius and ask the user to input what is the radius of the circle. That means include the following command in the script file before executing file theta. Ask the input on the screen, that is r is equal to input, enter the radius of the circle and modify it with x and y, calculate appropriately. Save the file and execute that. For example, if I want to do with the second problem, so what is saying that you just write this r input. So input is the command which we, so it says that enter the radius of the circle. Input is a command in which take the input from the users. So what are the changes I have to do here in x and y? Yes, guys. What are the changes I have to do in x and y? If I have now r is the radius. Yes, anyone? I just put r star because when you have a circle, now the circle with the radius r, so the coordinates of that will be x is equal to r cos theta. So that is r star cos theta and y is r star sin theta. And then I'm just running this file. So see in the command prompt it is saying that enter the set radius of the circle, and that's the value stored in r. So I'm just typing 5. So r is 5, and you can just see that in the circle it is changed now. The radius of this circle is 5 now. That you can see. Okay, because it is 4, so it is 5 here. So that's why you can change this. Okay. The next one that we are doing. So this is the first I'm giving you as a homework, that modify the script file and plot the center with the plus sign. That I'm giving you as a homework. Yeah, in the entire lecture I'm giving you lots of homework because it is not possible to cover everything with this. So, and it is hands-on training, so that is better that you can do it. So variable in workspace, we already have said that there are variables in the workspace. So if you can see what are the variables you have already available in the workspace, then you just type a command called who, and you can see the all the list of all the variables which are available in the workspace. For example, right now in the workspace there are this many variables, and just I'm typing who, then your variables are, so it is gives me all the list of the variables. Then type the who's to get the information about the variables and the workspace. So that means here the a variable is numerical and all sort of things is there. This is a vector. So if you can type who's and just put enter, then it will gives me all the information about the variables. What are the variables is there? What are the bytes of that variables? What is the class file? What is the class of that? All sort of the information is there. So there are two commands, who and whose, which gives you about the variables which are available in workspace. If you want to clear everything what is in the workspace, then you just type clear. Then whatever the variables you have defined in the workspace, all the variable is removed. So clear, you can just see that in workspace there is nothing is there now. And one more thing I want to tell you here is that if I can just define x is equal to 3 here, and again if I define x is equal to 4, then it will rewrite the value. Whatever the variables you have done there, it will rewrite the value. So here previously it was 4, right now it is 3. Okay. So whatever you are defining the variables, which when we are working with a larger command, that is most important, because sometimes it is happen that it is overwrite. So MATLAB is overwriting the variables, whatever the variables you are defining. So by typing this theta, x and y, to see the variable values of theta, y, x and listed in 3 columns. Okay, so that you can do it yourself. A content of the file, to see the content of the file, you just look for, there are lots of commands are there. As I already just say that help command is there to see what is the few lines of the, but if you want to see that what is the content of that file, that means what the circle.m file contains, what is the command, what are the command lines you have written in that. So for that you have a command called h1. The first few lines are called h1 lines. As I told you that in help you can see that first few lines of that command. Look for is command is used for keywords for description. That means you suppose you have a lots of files, you have created lots of .m files, and from that you want to look for something which you have remembered. So that is command called look for. Look for unit to come up with the the list of script file is just created. So you have just created the script file and you want to looking after something into that file, that also can be there. So and this type circle.m will gives you entire content. Okay. And this is one more exercise I'm giving you as a homework, that just for fun you can just do that. Write a script file that when you execute it, grids you display date, time, and your favorite person. To see the commands how to display is there, the command that will display whatever you want. A date command is already available, clock is already available, whatever your computer clock is there, it will be showing you. And when you're using the clock, you can just pick that and see the online help command this execute them. Okay, so this is just I'm giving you as a some exercise here to do this. Now the next things is to write a function file. So what is our objective is to learn how to write and execute the function file and different between the script and function. So there is a difference between a script file and a function file. A function file, for example, n factorial is a function and n is a variable. So likewise, there is a difference between a script file and function file. A script file gives you lists of command. A function file, it have a list of command, but it has some objective of that function. So script file, it's just like a script file, except that the function definition on the top of that is defined. Okay, so the first line which we have here in the function file, it is a function definition. And how to open and edit M function file, that I already explained you. Just go to this, or you can go to your window, double click on it, it will open it. So here I already open this function circle file is there. Create a function file to draw a circle specific radius with the radius as input function, and you can either write a function file and scratch from the modifier. So whatever we have written here, you can just modify this file, or you can create a new file and write as a function file. So yeah. So this is the things we need to do. So what we can do, let me create another file to create this function, how to create a function into the MATLAB. So the first command is function, and then there are variables. So I'm just defining two variables here, and equal to that is a function name. Now the function name, I'm just saying it is circle function, and the function round bracket, that is r, so that is the value of r we have. Okay, and then you can just write some description about what is this program is. So it is a function to draw a circle of radius r. Okay, so what are the input variables you have? Input is r, which is gives you a radius, specific radius. Then what are the output variables? You will have x and y. They are the two output variables which gives you the x coordinates and y coordinate. Of that data points, whatever data points we have. Then we have a theta. So I'm just copying from this here. This is my theta. Now there is no need of this line because the function already have that r here, and I'm just copying this x is equal to x cos theta and plotting the function. Then axis equal. Now it is not circle of unit radius. Now it is a circle with radius r. So it is circle of radius r equal to. Okay, then I'm just writing numerical string of r. So this numerical string is printing whatever the r variable contain. Okay, and then I'm saving them. So when you save this command, the script file, it's automatically have the same name, whatever the function name you have defined. So it is circle function. If you can just try to rewrite this as a different command, different name, then it will not execute. Okay, so it is in MATLAB, whatever the function name you have defined a function on, that same name is of your script file. So this is the function that I have created. Now I'm just running. So that is another way is to call this function. Save them. Now I'm just defining what is my small r is equal to, let's say 6. So r is 6. So these are the another ways to call this function. X and y is equal to circle function. So this is the circle function I'm just writing. The value r and then put n. So what is it will create? It will gives me the value of all the values of x and y. What is x is equal to, what is y equal to, as well as it will create the circle with the radius 6. So in the new window is pop up, and in that they have created this. Okay, so this is the way you can create a function. There is another way is to call the function. Just write circle function. Let's say 4. So just it will create x axis, y axis, and created the circle with the radius 4. So these are the different ways you can create a function and execute them. For example, you can also do it in this manner. Circle function, you have some commands you call also you can write. For example, r square. So r is a variable. I just write down r square. That will give me square of r. R value is 6. So the square of that divided by r plus 5 star. Uh, let me say sine of r. Then also it will create a circle with that radius. So it is the radius of that circle is now 4.69, which is printed here. Okay, so whatever the value I have typed here, something MATLAB has calculated this value as r, and then it gives me the output of that function. Fine. So I hope that how to create a function in the MATLAB, it is clear to everyone. Let's move forward. Shall I? Or you want the time to execute the command? Okay. Let's move further. These are some exercise I'm giving you as a homework, because if you want to learn MATLAB, then you have to do a lots of exercise, and as the time goes, you will be expert in that. Okay, so that is the better ways to actually learning any programming language. So this is the first way, I can say exercise, that is calculating a factorial. So write a function factorial to compute a factorial n factorial for the integer n, and the input should be a number n, output should be n factorial. You might have to use the for loop and a while loop to do the calculation. Okay, so I'm just giving you some idea. I'm not giving you entire function, but I'm giving you some idea how to deal with or how to come up with this. So let me define a factorial. I want to calculate the factorial of 10. So I'm just writing n is equal to 10. I'm just running as I told you, you need to use the two loop, either for loop or you can use a while loop. So here I'm using a while loop. Okay, so while n is greater than 1, and I'm defining one variable called fact is equal to n. Okay. So if n is greater than 1, the value of n is equal to n minus 1. So it will reduce one value. A fact is equal to fact because we know that the factorial is that value multiply with the previous value, that is 1. 2 factorial is 1 into 2, 3 factorial is 3 into 2. So it is whatever the answer you got in previously, you have to multiply the next integer with that. So it is factorial or fact into x, sorry, n, and then and this, and then display what is this fact after all. Okay, so here I have just already defined what is n is. So I'm just running all this command. Select, press F9, and it will give me the answer of that factorial. Okay. So this is just I'm giving you, this is not the function. You have to create a function like this. This is my exercise, and I'm giving you as a homework that you have to create a function like this. The objective is this called factorial. A factorial is also already available. See, factorial command is already there. Factorial of 10 I already calculated using this while loop, and inbuilt command is already there, factorial 10. So try to give the another name, factorial 1 or fact whatever. Okay. Give the command that name and do it. This is another exercise that I'm giving you, that is convert the temperature from Celsius to Fahrenheit. Okay, so this is the formula already I have given here, and try to do this. Computing the cross product, geometric series sum. Okay, so these are the small exercise that I'm giving you to hands with the MATLAB, and then later on, after sometimes, you will see that what is the difference by doing this exercise you will have. Calculating the interest on the money, the formula is given to you, can calculate. Okay, so these are some exercise that I'm giving you as a homework. The next one is the doing the calculus with the MATLAB. That means MATLAB has command for most of computation basic calculus in the symbolic math tool. So that is the symbolic math tool is there, is available, which gives you a symbolic computation. For example, till now in the previously what we have considered, x is a numerical variable. So x has a vector or it is a matrix. So it is have some numerical computation. Here it is a symbolic math tool is there, which treated the x variable as a continuous variable. And this tool includes parts of separate program called MATLAB, which is process of symbolic calculation. So whatever the symbolic calculation is there, for example, if I want to do the differentiation of d by dx of sine x, okay, or some complicated function is there, then using MATLAB, you can do this integration of something, sine x or whatever the complicated functions are there. So that is whatever the calculation or whatever the things is doing by this, it is known as a symbolic math tool, which is already inbuilt in after I think so 2006 MATLAB, it is there. So what to do? So command is this: to define a symbolic variable is syms x. You just when you type in command window syms x, so you just taking a time, and in the workspace you also see that my x now it is 1 by 1 symbolic variable. So this x is a variable, it is a symbolic variable. Okay, and the next one that I need to do is differentiation of this x cube. Okay, so this is the command to calculate a differentiation of any function. If you have, then the diff is a command to calculate the differentiation of that. So it is says the answer is 3 into x square. That we know that the differentiation of x cube is there. Instead of this, you can just type whatever the complicated function is in there. Okay. The alternating way is to do this. You just define a function. So f now I'm calling as a function and defining as inline. So inline is a command and defining the function x cube. What is my variable is x. So x is my variable and x cube is a function. So if you can just see that inline function is f of x is equal to x cube. So this is the way you can define this function inline x cube x. So it has a function f of x is equal to x cube now. Now you just type differentiation of, that is the command diff of f of x. So it will give the same output. So these are the two ways you can do this. Okay. So this is the first way, that by doing in this manner or by doing in this manner. So these are the two ways you can do the differentiation of any function. If you have some complicated function, try for that yourself. Okay, suppose I want to calculate the second differentiation or nth differentiation. That means I want to calculate the successive differentiation of the given function. Then the command is differentiation of f of x. Already have a define a function, that is x cube is already defined. Then you just put comma, let's say 2. So it is gives me second time differentiation of that. So second differentiation. And we know that the first derivative is 3x square and second derivative of that function is 6x. So it will gives me this. For example, let me try with the another way is to doing this differentiation of the differentiation of sine. Okay, let me, yeah. If you have more variable, that also can be done. That means first of all you have to define a symbolic variables x, y and z. X is already defined, I'm defining again. So these are the three variables now I have defined, and trying to differentiating the function, double differentiation of or differentiation of the function sine of, or trying to differentiating a function, partial differentiation of some function. Let's say sine of x square plus y square, and with respect to, I want to differentiate with respect to y. Okay, so this is the differentiation of sine x square plus y square with respect. So it will give me a partial differentiation of the given function with respect to y. Okay, and we know that the differentiation of this function is cos 2y. So that will be the answer. Okay, so this is the way you can do it. For example, wanted to differentiate, or for example wanted to find or calculate the ordinary differential equation like x dy by dx plus 1 is equal to y. So if you want to differentiate this function, sorry, not differentiate, but if you want to solve this differential equation, first order differential equation, then there is a command called dsolve. So if I have this one, then there is a command called dsolve. Then you can put in inverted comma x star. This is my x. Dy by dx is nothing but the dy, capital dy. That is a derivative of x, sorry, derivative of y with respect to x. See, I already defined the variables x and y. They are symbolic variable. If you are not define it, you will have error here. Okay. So plus 1, that is the function, plus 1 here equal to y. So equal to y. And what is your variable here? It is x. So this is the command to solve any differential equation. First order, second order also you can do it. Okay, and it will give me a warning that the characters or vector string will remove for the future release and symbolic, and the answer is some constant times x plus 1. So this is the way to do the or to solve differential equation of the given function. Then MATLAB can be computed okay, let me wait. Somebody has says that thanks professor, I got lots of with the differentiation part I was doing along with you. Fine. Then let us wait for some participants, they are doing with me. Okay, now hope so I have given enough time to do this. Shall I move? Okay. Next one is to do the integration, finite, indefinite and definite integral. The command is this integration of x square function with the variable x. So I already defined the symbolic variables as x. So let's say integration is the command int of let's say exponential of x power 20 x. X is my variable, so I need to put it in a comma, inverted comma. Okay, so the incorrect argument. Okay, what is the problem? See, if you type up arrow key, it will gives me the previous command which you have written. Okay, what is the problem here? Right, incorrect data, like missing the other. Okay, let me check the help. So whenever you want this integration part, if I want to see that, then it will have state the function. . document for why it is not working. Should be this. I don't know why it is not working. Should work.
We always simply use only function. Please remove the commas.
Okay, inverted comma. Inverted comma.
Yes, yes.
Okay, okay.
Yes,
okay.
yes,
Inverted
sir.
comma.
Yes, sir.
Okay, okay. Inverted comma is.
Yeah.
Yeah.
Thanks.
Done.
So
हेलो
yeah.
हेलो गुड इवनिंग हाँ बोलिए सर बोलिए
So this is the integration of x cube or any function you can just type sine of
नहीं सर
x.
अभी कॉन्फ्रेंस चल रही है हमारी मैथमेटिक्स की इंटरनेशनल तो ज्वाइन कर रखी है उसमें है हमारा ही पार्ट मैं
Okay,
कर
very
लेगा
good.
कोई दिक्कत
Integration of sin x is equal to
मैं कल
minus
आके
2.
लेगा ओके थैंक यू
Yes, very good.
Yes, thanks.
Can you take here, Professor Prashant, 10 of x by 2. 10 x by 2, take it.
Integration of 10
10 x by 2.
Okay, so this is the way you can integrate. If you want with the limit, then it is
Okay,
sine
okay,
of
okay.
x 0 and 1. This is the answer, sir, for 10x by 2.
Okay, okay. This is the answer.
And integration of sine x between 0 and let's say pi, then this is gives you a definite integral. The answer is 2. Okay, so this way you can have the integration. Same way there is a in MATLAB there is a numerical integration is already there. So these are the some command quarter date. So like Simpson's 1/3 rule and all sort of rules is there. There is a quarter rule is there. So these are the different place integration is there. So there is a numerical integration is available. So in the MATLAB later on new version after the MATLAB 6, these commands are already there. Okay, so these are the some example of that numerical integration is shown here. A double integration also you can compute. So I have two variables here, x and y. Suppose I want to calculate this double integration from 0 to pi, 0 to sine x square plus y square dy dx. So write down this integration x square plus y square. So whatever the first variable, that is, these are the limits of y, because it is a function of x, so it is a limit of y. So that first
Double
is
integral.
there. Double integration. So it is integration. So it is a double integration
Okay.
there.
Very good.
This is the function x square plus y square. And then dy. So what is the first variable? It is the limit of that y.
Okay. 0 to sin x and then 0 to pi.
Sin x. And then another variable is x. So MATLAB is automatically understood the another variable is whatever the left is. So it is 0 to pi. So this is the command to calculate such integration. Okay, let us do it in this here. So it is integration of integration. Let's have the function is sine or tan x plus y divided by 2. So I just write x plus y divided by 2. The limits of y. So the limit of y is, let's say, 0 to x. Then the first integration is over. The second integration limit is 0 to 1. Okay. So if I put enter, okay, I have not defined the symbolic variable y here, because in my workspace you can see that there is no variable y defined. So I'm just defining symbolic variable y, up arrow key, pressing the previous command, and now it will calculate what is this double integration is. So the answer for that double integration is this. Okay. Now how to find the limits into the MATLAB? So the command is limit of sine x by x. Symbolic variable x I'm defining. X and y. So command is limit of sine x by x. The variable is x and I want x tending to 0. So this is the limit function variable and the limit, whatever the limit you have. Another argument is left limit, right hand limit. So that is also where you can just adding the arguments. So here I want x tending to 0, a limit of sine x by x. So the answer will be 1. Okay. For example, I want a limit of absolute value. So AB is the command for absolute value of x divided by x. X is the variable, x tending to 0, and I need the left limit of that. Okay, so limit of absolute of x. So here I'm just doing this mod x by x, limit of x tending to 0, and left hand limit of this. Okay, so if you put right in inverted comma, then it is abs. Okay, so the command is abs for modulus minus. So it is, the answer is minus. If you can do it, suppose I want the x tending to minus infinity. Okay, so the limit x raised to 4, let's say the function is x raised to 4 plus x square minus 3 divided by 3 times x raised to 4 minus log of x the variable is x and x tending to infinity. So infinitive can be written in this way, INF of this. And put enter, it will gives me the answer 1 by 2. So in this manner, you can just do it for finding the integration of any given function you have. Then sum and product. Suppose I am defining the variable x is equal to 1 to 10. And so it will create the vector of having 1 to 10 variables. So x is equal to 1 to 10. And then sum of x. So it will gives me sum of x gives me sum of all these numbers which we have 1 plus 2 plus 3 plus 4 up to so on 10. Next one is a product of x. So it will gives me a product of all these numbers and it will have this answer. Okay, so these are the function product and sum and product. Suppose I want to calculate this finite limit of this. Right? So what is the sum is there? Summation running from 1 to n, 1 by k minus 1 upon 1 plus k. So how to calculate this or how to do this? A symbolic sum of k and n. So I'm just defining a two variable k and n as symbolic variables. Symbolic sum, that is a command called symbolic sum. Our sum which we have, it is 1 upon k. So 1 upon k minus, just putting brackets here, 1 upon k minus 1 upon k plus 1. A limit you want, that means the summation is running from 1 to n. And the limit is 1 to n. Okay, if you put enter, so it will gives me this answer. Piece function n plus 1. Piece function n plus 2. What is piece function? That is also a special kind of function. Special function is there. That you can see what is that function is there. You just put help piece function. It will gives me all the related. What is this piece function is? It will gives me information regarding that. So it is a polygamma function or digamma function, which we know as that function. That is a derivative of logarithm of a gamma function. That is this psi function is there. For example, I want to calculate the sum of so it is a symmetric sum of 1 by n square. The limit is from 1 to
Prashantkumar ji,
yes.
please close the script file window. Please close the script files. Yes.
Yes, it's done.
Yes. Now it's fine.
Okay. So it is a symmetric sum of this 1 upon n square. Suppose I want to calculate. Okay. So it gives me a summation of 1 upon n square limit from 1 to infinity. That is this. This quantity, if you want to calculate, then the answer is pi square by 6. And that we know. Suppose I want to calculate the geometric sum of a given number. Okay, so I'm just defining symbolic variables a and k. Symbolic sum of a power k. Limit is from 0 to infinity. Okay, so it will gives me answer. As you know that the summation of a power k, k running from 0 to infinity, its conversion, and if it is conversion if a is less than 1, it is between 0 and 1, then it is conversion. Otherwise it is divergent, that we know. Okay, so mode a is less than 1, then it is conversion, otherwise it is divergent, that we know. So it MATLAB is also understand that thing. That means if your value of a is absolute value of A is less than 1, and then it will give me this answer 1 minus 1 upon A minus 1. And if it is smaller than that or otherwise, it will give me infinite. So that is the way MATLAB understood that this series is diverse for the values of A if it is default. The next one is the Taylor series. The Taylor series expansion. So you can use the Taylor series expansion to generate a Taylor polynomial. So I'm just defining symbolic variables x, and the command is Taylor. The Taylor command will gives me a Taylor series of that, and it will have this arguments. That is f. The first one is a function, second one is a variable, and the third one which we have here a, which is about which point you want a Taylor series. So let me calculate the Taylor series of exponential of x with the variable x. Then it will give me up to some power. It will give me up to fifth power of this Taylor series of p power x. Suppose you want a Taylor series up to 10 order, then it will use me up to 10 order. No, it is not. Sorry, as I told you, this is sorry. This is the about which point you want. So it is a Taylor series about the point 10. So here it is 10. So it is the Taylor series have x minus 10. So it is about that up to fifth order. It will compute. So in that manner, you can also calculate the Taylor series of many a function. The next one is solving a differential equation. Solving a system of linear equations. That is, Ax is equal to b. It's this type of equations are there. So matrix equation. That is, A is a matrix, X is a column vector, B is a column vector. So if you want to solve this, we know that it has a solution if A is invertible, unique solution if it is A is invertible. So this is the command. Just you have to type A, means this black slash B. Okay, and then it will compute what is the value of X. If A is non-singular, then this is the command. If either A is or B is symbolic, rather it is numeric, then you can have, if it is a symbolic variable, suppose A is a matrix, but there is a symbolic variable is there, then also you can have to compute this with this command. That is, X is equal to symbolic of A backslash B. For example, let us do it. Let me have this vector, sorry, matrix A is 1. So how to enter a matrix into the MATLAB? So whatever the column, suppose I want to enter a matrix 1 2 0 0 1 3 0 0 4. Suppose I want to enter this matrix. Then the first entry is a column. This, sorry, row. So this is 1 comma 2 comma 0, and then one comma 2 comma 0, then semicolon you can put. So that will shift to the, your cursor shift to the next entry. So now it is 0 comma 1 comma 3, and then semicolon. So that move to the next row. So it is 0 comma 0 comma 4. So this is the matrix A is there. It's look like this. So 1, and you can just see that here into the workspace, the vector A or this matrix is having this entry. So A is a matrix now. B I want that is in column. So let me enter the B matrix. Let us say that B matrix is 1, 1, 1. But when if I want that is in column, so it is 1, semicolon 1, semicolon 1. So this is my B matrix. Okay. The another way also we can do it, this thing. Suppose I just put the comma. So it is now row vector. There is a command called transpose. Transpose of A, sorry, transpose of B. So this is the small b equal to transpose of a small b. So it will gives me this transpose. That is a different ways to enter the matrix into the MATLAB. So now we just type A \s b. So it will have the solution of this differential, this linear equations we have. That is, the linear equations will be x1 plus 2x2 is equal to 1, x2 plus 3x2 equal to 1, and 4, sorry, x3 here, and 4x3 is equal to 1. Yes, you know that x3 is 1 by 3, sorry, 1 by 4. So 1 by 4 is 0.25. And similarly, you can have x2 and x3 from this equation. So this way you can solve the linear system of linear equations using MATLAB. Okay, then you can have the eigenvalues and eigenvector of the given matrix, but by clicking on the command called IEIG is a command, and it is the arguments which we have. Okay, so if I can put A, it will understood that A is a square matrix. If it is square, it's not a square matrix, it will throw you an error. So it has to be a square matrix. If I put enter, then it will have three eigenvalues 1, 1, 4, and we know that this matrix is a upper triangular matrix, and the diagonal entries are their eigenvalue 1, 1, 4 that we know, because it is a special kind of matrix is there. But if it is not that kind of matrix, then also it will show you what are not even 3 by 3. It will, if you have 20 by 20 matrix, then also it will compute the eigenvalue for any matrix. Let me do it in this manner. That means I'm just writing as a eigenvalue. I want eigenvalue as well as eigenvector of a given matrix. So I'm just having this U is, sorry, R will be a diagonal matrix and U is the eigenvector. U will give you eigenvector and R is so the command is the same. Just I'm putting this arguments here in front of this command. So now you just put a U. So that is the vectors, which is you have eigenvectors you have. So and what is R is this 1, 1, 4. So corresponding to 1, 1, 0, 0 is the eigenvector. Corresponding to this one, minus 1, 0, 0 is the vector. And this is for third one. So this is the way you can compute not only eigenvector, sorry, not only eigenvalues as well as eigenvector for the given function. Sorry, for the given matrix. Fine. Now let's move for the next task, that is the plotting of some function into the MATLAB. As we already have mentioned that how to plot a circle. Now this is the command which I have written few lines here to plotting a sine function. So that I am doing in the script file. So in the script file, I'm just defining one variable. So first of all, let me clear everything whatever I have defined here. So to clean the workspace, I already told you that clear is a command to clean the workspace. Before that, in my workspace, there are lots of variables are defined. Nowadays, nothing is there. And CLC command is to clean the command window. CLC. Okay, so that will clean the command window. Now, I have opened the script file, and then let me try to plot a function. So first, I'm defining one variable called line space. 0, 0 star 2 pi. So in between 0 to 2 pi, in between 0 to 2 pi, I want 100 points. You want 10 points, you can put 10 points. 1000 points, you can, up to you. So the first argument is starting point, second argument is ending point, and the number of data points you want in between. So that is the things you have. So this is my variable x. Then plot. Let us plot the function x versus sine x. And pattern of that one is let's say 0. So every time it will plot 0, 0, 0 into the line. Axis putting as equal. So there are lots of arguments of the axis. Title of the that graph I'm just putting is plot of sine of x in 0 to 2 pi. Just selecting all of this and pressing F9. Some error is there. Air plot valid color market style. Okay. I need to change this type. Okay, so it is plotting the function in this manner. Suppose I have some parametric equation like x is equal to, let's say, sine t, y is equal to cos t, and z is equal to t. So as you know, this is the helix. This will represent a helix like this, okay, in 3 dimensions. So it is the 3D curve. If you want to plot a 3D curve, then the parametric equation of that 3D curve, this helix, this is called a circular helix. And the parametric equation of this circular helix are this: x is equal to this, y equal to this, and z is equal to this. And if you want to plot this one, so here the variable is t. So first variable you need to have a data points in it. So let us have the variable t is equal to line space 0 to 20 and 100 point in between 0 to 20. Let's say x is equal to sine t, y is equal to cos t, and z is equal to t. Putting semicolon, so not displaying the output. And plot 3D. So that is a command to plot a 3D function. See, there is in this newer version of MATLAB, also here is a function called plot. When you define some variables in the command window, it's automatically some suggestions will be comes up. So these are the lots of plots functions are available in this. You can see that. Okay. So 3D plots, bar plot, scatter plot, contour plot, surface plot, mask plot. There are lots of now availability also, but it will be appear once you define a variables here in the command window. So for example, if I put F9, then I'm putting this 3 variables, defining this 3 variables, okay, and then plotting the function called plot x, y, z. So you can just see that circular helix will be plotted. Okay, so this way you can rotate this circular helix by selecting this 3D rotation is there. You can zoom in and zoom out. So lots of you can play around whatever your requirement, and according to that you can save it. This figure you can save, file, save as, whatever the requirement you have, you can do with this figure plotting arguments. Now let us have the third one, is a plotting a surface. So I'm just taking one example. So first we have taken an example of plotting a curve, okay, x-axis and y-axis. Secondly, I have taken an example of plotting a curve in 3D plot. That means in 3-dimensional curve, how to plot. So you require a parametric equation for that. Now let us try to plot a surface. Okay. So as you know that the surfaces are equations. So let's plot this. X is equal to x1. I'm just defining x1 is equal to a line space of 0 to 5. Points I'm taking 200. The same thing I'm copying and defining the variable y. Okay. Defining the variable y. Defining in square bracket xy. Command called mass grid. So I'm just making a grid of x and y. So I have an x-axis and y, x1 and y1. So an x and y is a grid of everything is in 2. So 0, 0. Then in between 0 to 5, there are whatever the 200 points are there, it will make a coordinates x and y. So that command is called mass grid of xy. Putting a semicolon, then plotting a function. So I need to plot this function. Let's say z is equal to 3y plus y cube minus x cube. So this is my surface. As I told you, a surface is a function of 2 variables. So these are the 2 variables in there, and I want to plot this function. So for that, what I did is I just creating a grid of xy. So x coordinate is there, y coordinate. So I have just created x1 vector and y1 vector. So it will have this value and this value. So it will have created now this mass grid will created now the points x and y points. Now what is my function is this 3y. 3y means 3 star y. 3 star y. Plus the next one is y cube. Now here what is the problem? If I put y cube here, then this y is now not a variable. Let me run this one so you can have to understand what is the meaning, what I'm talking about. So just see that What is my x1? Here in my x1 is 1 cross 200. Y1 is also 1 cross 200, but your x is now 100 cross 100. So this x is now a matrix. Y is also a matrix, 100 cross 100. The dimension of x and y is 100 cross 100. But when I type this x cube, so if I can type x cube here, then what is this output is gives you, it will gives me a cube of every number. For example, suppose I have x is, suppose I have a, let's say s is equal to 1 to 10. Okay, so this s is 1 to 10 is there. Now if I write s cube here, then it will throw me error. Okay, so because error function is incorrect dimension of the array, so it is a not having the same. So the y cube is actually gives you a pointwise multiplication of that, but I want a matrix multiplication. Sorry, I want a pointwise multiplication. So that's why it has to be dot here, a dot y cube plus, sorry, then it is minus x dot y cube, sorry, x cube. So why I have put a dot here? Because to do the pointwise multiplication. And then I'm just running this. Okay, so that will create now this vector. Sorry, this matrix. So x, y, and z now are the three matrix, 100 cross 100. So you can just see that x is in workspace. You can see that it is 100 cross 100, y is also 100 cross 100, and z is also 100 cross 100. Now you just see that here in my plot window there is a, everything is up. Before it was not showing up, but now it is showing up. That since I've plotted this, since I've input this variables here, that's why it is showing what are the availabilities of this functions you have. Now you can have everything. You can access any of this graphs you want, okay, as per your requirement. So mesh surface is the command, surface plot. You just click on here also, that will gives me same thing. So it will gives me a surface plot of that graph. Okay, you can have a 3D rotation of that. If you have more points in between x and y, instead of 200, you just put 1000, 2000, then you can have a very smooth curve. To be x, y. So this is the way you can have. Still it is running because I have taken 2000 points, which is a very big, and it is processing right now. It's not showing the output yet. Still it is see. It's taking a time. And then I just give you one exercise. Can you plot this functions? Z is equal to sin x plus cos x. Try to plot this function. Sorry, sin x, it is a two variable. So sin x plus cos y. Try to plot this. Z is equal to sin x plus cos y. I'm stopping this because I don't want to waste the time. I take too much value. Fine. So till then, guys, you can just try to plot this function. Z is equal to sin x plus cos y. It's not responding. Okay. Fine. Let me close it. Sorry, it is. I have closed the MATLAB and because it was hanged, so I just close it and open it again. That will take 2 minutes. So, guys, you can tell me your feedback. Meanwhile, have you plotted that sine plus cos? Let me write. What you have to do is I already defined x is equal to line space 0 to, let's say, 20, 100 points in between. Y is also line space 0 to 20, 100 points in between. Then if I want to plot this one, I need to define I need to define a grade xy. I'm just saying rewriting the xy with xy is mass grid, or you can just type another variable capital XY, that also will fine. Mass grid of, it's not visible correctly, so I just, oh, let me write here. Mass grid of 0 to mass grid of XY. Capital X, capital. And then you just Z is equal to the sine X plus cos Y. And then surface plot. Surface XYZ. If you do this, you will have that. Fine. Next, that I'm interested in to presenting you guys that plotting a complex function. Many times what is happening is complex functions are plotting a complex function domain. Means those functions whose domain is a complex, and then sometimes many times we cannot visualize that function. Why we cannot? Because it is a, when you have a function w is equal to f of z, then this w is of two variable u plus iv, and z is also of two variable x plus iv. So actually there are four variables, and to understand these four variables, you require a four-dimensional things. And when you want to observe what is happening for that function, it is very difficult to see what is happening for that function as a four-dimensional, because four-dimensional things we cannot visualize. Yeah, mathematicians can do that, but many times physicists and engineers cannot rely on that. So here I'm just demonstrating that how to plot a complex domain function and how to visualize, not plot exactly, but how to visualize functions having a complex domain. So what I'm just doing, creating one script file here and defining symbolic variable x. Taking a time now. It's taking so much time. See, still it is running. F of x, I'm just defining as 2 star x square. This is a real valued function right now. I'm saying this is my function 2 x square 2x plus 2. Okay, so this is the function, and solve is the command to find out the roots of this equation. That means f solve. If I do this, I don't know why it is taking too much time. Still it is working, means I don't understand. See, what I'm explaining you is this: you solve this function. When you solve this function, it will give me a roots of this equation. That means 2x square plus 2x plus 2 equal to 0. When you have a root of this equation, we can see that the roots of that equation is not a real roots. It is a complex roots. Okay, and then I'm putting the clear command to clean everything up. Okay. Now a is equal to this and b is equal to this. I'm defining the variable a is -2 to 1. In between there is a space of 0.2, -2 to 2, in between space. So then creating a mass grid with this AB as we have did in the surface plot. And then plotting this means putting this y is equal to 2 star. This is z. Whatever, instead of writing this x, I'm just putting this a plus I, 1 into I, that is the imaginary number I, star b. So, and dot square. So that is gives me 2z square. Okay, so this is a 2z square. This is 2z. Instead of x, just putting a plus ib plus 2. And then using the surface contour plot, so C stands for contour, AB and absolute value of this y. Shows the real axis with x axis and y axis. Is it open? Yes. See, I have already have this file, so let me run that complex plot. Okay. See, I already have that file in my. I already typed that. So complex plot. Systematic x is equal to this, solved this. So let us run that one without wasting our time. So this is my function x, solving this f of x is equal to, so it will give me these two roots of that function. Then I'm just putting clear, so a workspace will be closed. Running this, defining this a and b. So a is my from -2 to 1. In between there is I need a space of 0 to 1. So it is a data set. Then creating a mass grid of this AB. Then defining this function y. That is, as I told you, that is 2 into z square plus 2 into z plus 2. Then surface contour plot. So it will take some time to plot the graph of that complex value function. So you can see that this is the graph of the function, and you can rotate. These are the 2 points which we can see here. These are the 2 points which are the roots of that equation which we have. These are the 2 roots of that equation which we have, a complex roots we have. And this is the graph of that function is look like. The below there is a C, you can see that there are the contours. These are the contour plot. This is a contour plot. And you can also modify that contour. So there is a toolbox from here, open property instructor. So you can do the lots of things with that also. Computer is slow, so that's why it is taking time. See, this in the property plot, you have lots of arguments here. As per your requirement, you can change the x thickness, y thickness, font size. There are other search. You can just search for example, I want a contour. You can just search for that also. Lines. If you want the line size is on a different way, contour plot. So color you want to change. So there are lots of available objects are there. Okay, let's go back to that. Suppose I want x axis as x label, y axis as y label. That will be done. That is imaginary part of x, and y axis is that real part. Color z. So that will show me the color, different type of color you have there. Here it is. So, and then you can use lots of color maps are available. You just put the help color map. Then lots of documents available for color, different type of color maps are there. Okay, you can also Google it for the same. You want, in which way you want your graph look like. Okay, so this is the way you can have. Fine, let's move forward with that. So here I have just given some exercise to give you some idea regarding how to plot a graph, and with the same give you some exercise to do whatever I have done for this calculation. Okay, so the surface plot and whatever the things is. I think so. I have just few minutes for the time. I thought that I cannot come with this special functions, but let us have. Everyone know what is a gamma function, and gamma functions is a generalization of a factorial that you have, and it is defined like this: gamma of z is equal to 0 to infinity 0 t power z minus 1 t power minus dt. And it's have a recurrence relation gamma z plus 1 equal to z into gamma z. Okay, these are the some expression for the gamma function which we have. Let me try to draw this function. That means the gamma function plays an important role for evaluating a gamma function. This in the next figure shows the absolute value of a gamma function in a complex plane. As I told you, how to plot a complex function. So this is exactly the gamma function is defined for the complex variables also, and that function is look like this. So these are the inbuilt command for this MATLAB is already there. Let me close this. So gamma of 2 if you put, then the small g is there. So it is gamma 2 is gives me the answer 1. Okay, so a gamma inbuilt function is there already available for the MATLAB. It's written the gamma function evaluate the elements of x. Gamma 0.5, it have this answer. Suppose you want to evaluate the range between minus 3.5 to 3.5, then also you can have just defining the variable x is equal to minus 3.5 to 3.5, and y is gamma x will gives you this vector. The answer is of 1 by 8 operate means factor, which is having this value. So the first value is a value of gamma 3 minus 3.5 and so on. Okay. Plotting a gamma function. So that is command called fplot. Just typing this command fplot at gamma will plot the function gamma. See, you can have a gamma function. Plot of gamma function, two-dimensional gamma function is there. Okay. So just by having fplot, function plot, this is fplot stands for function plot. At the rate gamma. Gamma is inbuilt function by the MATLAB. So it will produce this function. You can modify it also. So here I have a put hold on. That means I want to put a two function on one graph. So if I want to create such function, then a command called hold on. So if I can put hold on here, then on the same graph, I can put two functions together. Okay. So fplot at x, so x is my variable, 1 upon gamma x. Okay. So this is what I'm doing. I'm plotting two functions. One is gamma function, another one is 1 upon gamma function. And y limit, I'm setting my y limit is minus 10 to 10. Legend, that is, I want to show that which graph represent which one. So for that, first one is gamma, another one is gamma 1. And holds of grid of. Grid means it will print the grid of that. So that is also, I think so, I have a command is there. So without wasting the time, I'm just plotting that. Okay. So yes, see the one graph which is a blue one, it's here. It says that blue one is gamma function and this orange one is 1 upon gamma. But as a legend, this is a command can be done by using a legend function. Okay. Now, the next one that I'm showing you is a plotting gamma function as a complex domain. So for that, let me clear everything from here. And then I'm just plotting x, means creating vector x, that is a line space of -4 to 300. So in between -4 to 300 points, y is the same. Then creating a mass grid of this xy. So xy is a mass grid. Now defining z is equal to gamma c. This gamma c I already means there is one library called physics, spec physics. The library name is functions physics. I will tell you about that also. So that is the gamma. Tell you about that also. So that is the gamma c function is already there, and putting that as x plus 1 into I star y. So I'm just creating a z variable as gamma c. It is an inbuilt function which is available in the physics of special function physics library. It is there. So that library I'm using here, and then it will plot. You can just see that. Let's plot surface plot, surface x, y, and absolute value of z. So it's absolute. See, in that I have told you that we need to plot that such graph, and you can see that there is a uh, uh, this is a two-dimensional things which it shows here in the two-dimensional figure. This is a three-dimensional. So here this is the way the curves are look like. Okay. So let us move forward now. I think so. Time is up. 47 is there. I have a lot to say, but I think so. Time is over, so it's better to stop. Before closing the things, I can suggest something for this. First of all, the open online MATLAB is there already available. You can download it trial version for 30 days if your institute is not providing MATLAB. The another one is there is a very good library and helping things is there. So that also I want to tell you. So that is a library called a special function library, and in that you can have lots of content is available. For example, you just click on Bessel function. So that is these are the different commands. You have beta function is command in the beta function. Suppose you go in depth, then they will show you what is the beta function is, what is the command for the beta function, and few examples for that. It's also how to plot such function. Okay, so so MATLAB is having a very good help that I can say is available, and also one more thing, there is one library called Niche Digital Mathematical Function Library. So this is especially for those who are working with the spatial functions. So this is the very good library. It is available, and here you can just see that lots of functions are there. Okay, so numerical methods, algebraic and analytic function, few hypergeometric related function, orthogonal polynomials, the zeta function, zeta and related function. So the spatial functions are available in this library, and this library have lots of version, and they will update after few time. Suppose I go to the gamma function. So in the gamma function, they have these are the subtopics. Suppose I can go to the graphics of that gamma function. So they will show you what I have plotted the function. It is shown here the same function. Okay, and then the different terminology, different type of graph, it is there, visualization of that graph, and so on. So there are lots of help is available. Google it, everything is available for you if you want to learn. Okay, I think so. I have from my side, I can stop here. If you have any question, you can ask. Yes, guys. And lastly, I just like to thank the organizer who has given me this opportunity to deliver whatever I know little bit of MATLAB. Thank you very much.
Dear participant, you are permitted to unmute. If you have any question, please feel free to ask. Yes, you can unmute. Dear participant, if you have any question, please you can unmute and ask the question.
So I thank you very much for your presentation, sir. The participant also learned a lot from you. So you have discussed many of lot of things here, creating a script file, solving a script file, exploiting script file, exercise also given, differentiation, integration, all the things. So, sir, here there are some questions in the chat box. We'll pick up a few questions. So, I request Dr. Prashantkumar Patel to please respond to this. So, how to solve initial value differentiation equation
Okay.
through the MATLAB?
It's there is a function called OD45. Okay.
Are you hearing me, sir?
It is. I think so. I'm on. Yeah. There is function called OD45. Okay, so that is using.
Okay, so all of you, I thank you very much, Dr. Patel and participant, for making it a very lovely session, this one. So thank you so much, all of you, for this session.
Thank you, sir. Thank you.
Nice. Proceed further. Maherchan, your voice not listen.
Sorry, I was not unmuted. Now I am audible? Yes. Yes, yes. Thank you, Professor, for your valuable thought in this session. We are getting many questions who are attending this session on the live streaming. They are asking about the content which are presenting in this session, and in the upcoming we will provide all the content through their email address, as well as feedback form will be sent on their email address. Okay. For the today, this session is all about over. Thank you all the participant and the resource persons for your valuable time. Tomorrow we will resume the first session 8:11:30. Thank you all of you, and it is time to close this session.
Okay.
Thank you, Prof.
John Edoga, you want to say something?
Not really, Prof. I say thank you for everything, and I do request that you try and make the slides available for